A keynote presentation by Parker Lord, Electrification Solution from Parker Lords. I would like to invite on stage Mr. Nirmal Bhagwat, Application Engineering Manager, Parker Lords APS Division. Everyone with a round of applause, one more time, please welcome on stage Nirmal Bhagwat.
So good afternoon, everyone. I hope all of you have good lunch and will not sleep during my presentation. Sorry for that last minute trouble in the first half. So we'll go for quickly some slides which I have already told in the beginning, in first half. So as you know, Parker has a global presence across the globe in 50 countries. We have some divisions, operating groups here. We belong to engineering materials group, out of which from LORD we have 3 branches, basically EPM, APS and NVH. So we belong to APS group of products, so which are basically thermally conducting materials. So as I said earlier, we have a lot of electrification solutions with us, like potting material, encapsulants for like battery packs, headlamps, onboard chargers, inverters, headlamps. So all electronic devices you said, we have material for that. So in this basically, we have all 5 chemistries with us, silicon, urethane, epoxy, acrylic and MS polymer. So each and every chemistry has their own pros and cons. So if you say like silicon based components, then they have very good for high heat resistance. Then epoxies are very good for chemical resistance. If you say urethanes and epoxy is very good for high strength. Acrylics are very good with which can replace actually, all kind of mechanical fastening methods, and that with also a good thermal conductivity. So we have those acrylic grades of products also. So coming to our portfolio, we have potting and encapsulation material with very low viscous material which can go through all the kind of gaps in battery packs. Then we have gap fillers, which is nothing but like a paste kind of material which could be applied over terminals in the form of bead. Then we have high strength structural adhesives which can replace all kind of mechanical fastening methods which generate strength more than 15 to 20 MPa. So very high strength adhesives which can be used for bonding like heat sink to cells. So these are basically gap fillers and potting materials. I will show all these videos afterwards. So these are some applications like in battery pack. So for battery pack, we have gap filler solution for like whether it is pouch cells, cylindrical cells or prismatic cells. Gap fillers can be very easily used between terminals and your heat sink. Which are basically very good for conducting heat from your hot spot to cold spot. Then, as I said, we have adhesives which are thermally conductive, having thermal conductivity of 1 watt per meter Kelvin, which could be used for bonding cell to cell holder or even for cell to heat sink bonding. Those adhesives can be used. Then we have, of course, potting and encapsulation material which could be used in your battery packs or motor potting or even onboard chargers, offboard chargers. This is basically about our gap fillers, how these gap fillers are, I can say, better than thermal pad, because if you go cooling plate, which is long enough, if you saw a macroscopic level, there will be some imperfections. So pads will be not covering all the gaps all the time. So you can see gaps over there, which could be, the probable hotspots. So here our gap filler being a paste kind of thing, they can basically go to all kind of gaps and giving you better results compared to the thermal gap pads. So it can cover all gaps and almost 20 to 30% better results than thermal pads. So this is the next big thing in the market. This is still under proto stage. So we are basically prototype adhesives for thermally conductive urethanes, which will be used in cell to pack bonding. So currently this is in prototype, not yet commercialized. Then we have applications in like onboard charger and offboard charger and also power electronics, where your life of your product gets enhanced due to this all kind of potting material. Almost we can say it can double the life of your original component. Like without potting and with potting, there will be difference of almost twice. This is best example of thermal management or in power electronics. If you can see that DC-DC converter, the bigger one is unpotted and the smaller one is with potted. So with our potting material, you can not only reduce the size of the component, but also you can increase the efficiency of your component up to 87%. So that is the beauty of these products. And at left, basically, we have shown some graph with our potting material with thermal conductivity ranging from 0.1 to 4 watt per meter Kelvin, and how the performance affects and how temperature rise is reduced up to almost 85%. So this is application in inductor motors, where basically you can get a delta T near about 50-degree drop in the temperature by using our potting material, and also your power output can be increased almost by 30%. These are the potting materials which are stable up to 200 degrees centigrade. The best example here I can show you where we have studied these motors with different material. So here is the first case you can see where same motor with same output at lower temperature with potting can be possible. Instead of 80 degree, the service temperature is 65. So with potting that can be possible. Or same motor with reduced size, but with same input can give you, it is possible with potting. Or the third case, like a same motor, but with higher input can result at with potting material. So these all are possibilities with motor potting with Parker Lord materials. And here you can see the delta time, T is near about 10 degree decrease in temperature, your life almost doubles. So these are the beauty of these products. So here basically we talk about structural adhesives. As I said initially, structural adhesives can replace all kind of mechanical fastening methods. So in EV industry, basically we have different kind of applications here for structural adhesives, like for module housing, then module leads bonding, cell holders bonding, battery box lead attachment, maybe sealing sometimes also. Then various metal to metal or even metal to composite or plastic bonding. These structures adhesives can be very effectively used. This is a variety of applications in pouch cell design, where cell to cell bonding, cold plate coating, we have some coating material also. So in next slide we will come to that. Then module potting, module sealing, enclosure sealing and enclosure coating. These are some applications in pouch cell design. Then these are the coatings, basically dielectric coatings. These are the coatings basically many customers ask about extra layer of protection, though they are using some potting material or something. So these are very good replacement for powder coating. So powder coating, they don't have that much coverage on the edges, whereas these coatings in microns gives you very good coverage on the edges also. So very high dielectric strength these products have. So this is a product JMC 700, which is a heat curable product, which is cured at 180 degrees centigrade for 20 minutes. And we have another coating which is a UV curable. So if you have a high volume of production, so your material can be cured in within 15 or 20 seconds. That is basically CPO UV coating. So this is the coating which is having 100% solids. The prior one was the solvent-based product. This is a solventless product, so 100% green product, which is UV curable and high dielectric strength at less than 130 microns of basically thickness. Then this is basically intracell silicon synthetic foam, which is another new product we have to have thermal mitigation in battery packs. So we propose like either if you are using potting material, then you can use gap fillers along with this the foam. This is synthetic foam, non-expandable. So this can be used between the cell basically to up to gaps of say minimum gaps of 1 or 2 mm or even 5 mm, whatever gaps that can be filled with this material, and which is FR grade. So it protects your battery from thermal runaway. Then we have thermal, basically for thermal mitigation only we have another product which is expandable PU. So this PU can be expanded up to 2 to 5 times after basically injection. This is again liquid product, 2-component product. After injecting into battery pack, it can goes to your minute gas of 1 to 2 mm also, and it get expanded up to 5 times. So the density of these products are near about 0.2 to 0.3 only, and the density of that previous product was 0.7. So these are very lightweighting, but this is again rigid foam, and the prior one was a semi-rigid foam. So these are some videos I will show you to show you. So this is basically gap filler application we have shown here. So these are like paste kind of thing which can be used between heat sink and your battery terminals. Then this is basically potting material, which can be used here, for potting out different microelectronics or electronic components or even battery packs. So these can go into smaller gaps as well. See. So very low viscous material, so it can fill those minute gaps in that coil also. So we have products ranging from 0.7 to 4 watt per meter Kelvin, and with all the chemistries like epoxy, urethanes, and silicone base. Then this is another video of that synthetic foam. So this synthetic foam is basically used for thermal runaway. During thermal runaway, it will protect your battery pack. So it can fill up, you can see all minute gaps between the cells very easily. This is 2-component material, basically silicone base. This is non-expandable. This is the slide for entire electrification solutions from Parker Lord, a big video. So that was I was having for today for EV industry, the solutions what Parker Lord can offer to you. So you can see the video, and thanks. So like all the different applications we are covering here, like right from coating, then these are basically thermal paste or gap fillers. These encapsulations or potting. Then we have structure adhesives, as I said, for housey basically, or for battery pack and battery door bonding. So in structure adhesives, we have both basically non-thermally conductive as well as conductive adhesives. Then these are coatings. JMC 700, this is dielectric coating. So these are the products from Parker Lord. Thanks for your patience. Thank you very much.